The third part of 8.5 is looking at paired proportions. So you're looking at differences between proportions now. So we are not looking at means, we're looking at proportions. So you're not going to be talking about your mu1 and mu2. Now it's going to be your p1 and p2. You still do not need to know any of the formulas as you go through it, because we're going to put everything in to our calculator, and the calculator will do it for you. Now remember, when you do proportions, you're running a z-test, but it's not a two-sample z-test, it's a two-proportion z-test. So you have to make sure you choose the right z-test. And you'll know if you choose the wrong one, because when you go to the two-sample t-test, or sorry, not t-test, z-test, as I'm saying my different letters, you should be doing a z-test as you go through this. But if you try to do a two-sample z-test, you'll see you need to have your X bar, your sigma, and you will not find that anywhere in your problem. So if you don't have those, then you have to be doing the two proportion z-test when you go through this. So I have the Mesa County clerk wishes to improve voter registration. One method under consideration is to send reminders in the mail to all citizens in the county who are eligible to register. As part of a pilot study to determine if this method will actually improve voter registration, a random sample of 1,250 potential voters was taken. Then the sample was randomly divided into two groups. Group 1, there are 625 people in this group. No reminders to register were sent to them. The number of potential voters from this group who registered was 295. Group 2, this group also contained 625 people. Reminders were sent in the mail to each member in the group, and the number who registered to vote was 350. The county clerk claims that the proportion of people who registered was significantly greater in Group 2. On the basis of this claim, the clerk recommends that the project be funded for the entire population of Mesa County. Use a 5% level of significance to test the claim that the proportion of potential voters who registered was greater in Group 2, the group that received the reminders. So we've got our alpha. Now instead of mu1 equals mu2, it's p1 equals p2 for our null. Now we are saying that Group 2 is what's greater. So you want to say p1 is less than p2. So we're going to go stat over to test, and we need the two proportion z-test. So now we put our numbers in. So your x1 is going to be your 295 because that's your r1. Your n1 is the total from that group 1, so 625. Your x2 then is going to be your total, or sorry, your r from your second group, so 350. And then your n2 is your total, so that's your 625 from group 2. Now we're looking at less than. So I need less than, and we go down to calculate. So when I have this, I have a negative 3.11. Now next, they are writing that in scientific notation. So when you write something in scientific notation and it's a negative number, you have to move your decimal that number spots to the left. So if you tell me your p-value is 9.2647, that's incorrect because you have to move your decimal 4 places to the left. So if I have 9.26, I have to go 1, 2, 3, 4. So here's my new decimal, and then you put zeros in front of it then. So if we want 4 decimal places, my p-value is 0.0009. Be careful when you have the e's. If you give me a e in your answer, you're not going to get all your points. So make sure you turn it into the decimal form. So now I've got my p-value, I got my alpha, and we are less than. So we're going to reject the null. So we're going to write our sentence. So at the 5% level of significance, there is enough evidence to conclude that the population proportion of potential voters who registered was greater in group 2. The group that received the reminders. Again, as you go through these, you want to make sure you find your parts. So every time you're setting up fractions, so you're looking at the total from your group, that's always going to be your n, and you're looking at then the part of your group, that's going to be your r, which on the calculator they call it x. So you're looking at two proportions to compare. So I'm going to read this one with you, then you're going to work on it. So in example 11 about voter registration, suppose that a random sample of 1,100 potential voters was randomly divided into two groups. Group 1, 500, no registration reminders, 248 registered. Group 2, 600 registration reminders sent, 332 registered to vote. Do these data support the claim the proportion of voters who registered was greater in the group that received reminders than in the group that did not? Use a 1% level of significance. So again, go through this, pause the video, and then come back and see if we get the same answers. So for your alpha, we got 0.01. For your null, we've got P1 equals P2. And now they want the next group to be bigger. So they want P2 to have the greater amount, so we have less than. We're going to type everything into our calculator. So stat, test, again, 2 proportion, z-test. So our x1 is 248. Our n1 then is 500. Our x2 is 332. Our n2 is 600. And we are less than again. So we're going to calculate. So we've got a z then of negative 1.90, because if I round to 2. Your probability is 0.0289. So I'm going to compare 0.0289 to 0.05, and we are less than, sorry, I have the wrong numbers, 0.01, which will change some. So if I have 0.0289 and 0.01, we're not less than, we are greater than for that. So since it's greater, you're going to fail to reject. So we have them at the 1%, not 5%, so 1% level of significance. There is not enough evidence to conclude that the reminders increased the proportion of registered voters. So again, for your P's, you're looking at proportions when you're going through these. So you're not looking at population means, you're not looking at mu's, you should have P's for your answer. So it's your P1 equals P2 instead of your mu1 equals mu2.